All right, this is quadratic transformations. Okay, so we're looking to describe the transformations from a parent graph to a new graph. So let's say we have f of x equals x squared. That is a parent function of a quadratic. And how does this function look like? What does it look like? Well, in order to graph f of x equals x squared, you can use obviously Texas Desmos. Let's go ahead and do an XY table. So, what if we were to do 0 squared? Let's put a 0 in for x. 0 squared is 0. 1 squared. What is 1 squared? 1. 2 squared. 2 squared is 4. What if we went to 3 squared? 9. 4 squared. 4 squared, 16. Let's try negative 1 squared. Negative 1 times negative 1 is just positive 1. Negative 2 squared is 4. Let's try negative 3 squared. That's 9. Okay, that's all you really need, to be honest, usually to plot a quadratic, or at least the ones that we're doing. You're going to go ahead and plot this, plot the points. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, 0, 0. 1, 1. Over 1 up 1. 2, 4. Over 2 up 4. 3, 9. 6, 7, 8, 9. 3, 9. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. That is 9. Okay. 1, 2, 3, up 9. Okay, let's go ahead and try negative 1, 1. Negative, you don't really need the 4. That's why negative 2, 4. It should be symmetrical because this is a symmetrical shape because these numbers end up repeating, right? 1, 4, 1, 4, 9, 9. Negative 2, 4. Negative 3, 9. Okay, what shape do you notice? This is like a U shape, right? Like a smiley face. We call it a parabola. This is your like basic parabola in its basic location, and our vertex is 0, 0. The vertex is h, comma k. Okay, what if we transform this equation to look like something else? So let me give you the basic format for a quadratic in vertex form. It's a times x minus h squared plus k. This is a basic parabola. It's just x squared only, which looks like this shape with the vertex of 0, 0. What if I change it and I said, let's instead graph f of x equals negative 2 times x minus 1 squared. We'll say plus 3, okay? It doesn't matter. I'm just making up an equation. And we're going to figure out what is a transformation. Did the parabola shift left, shift right, shift down, shift up? Well, there's a few ways to do this. Obviously, you could just graph this in Texas Desmos or any graphing calculator and see the difference between the two. You also need to know what your A value does to your graph, what your H value does to your graph, what your K value does to your graph. Let's go ahead and plot this by hand so you know how to do this by hand. Let's make an X and Y table. Over here to the side somewhere, I'm gonna go ahead and, well, I guess I'll do it right here. So what if I have -2 times 0 minus 1 squared plus 3? I want to try 0 in there, right? 0 minus 1 is -1. -1 squared is, -1 squared is 1 times -2 plus 3. -2 plus 3 will give you 1, right? -2 plus 3 is 1. All right, let's try 1. -2 times 1 minus 1 squared plus 3. 1 times 1, 1 minus 1, 0. 0 squared is 0. Times -2 is still 0. Plus 3 gives us 3. Let's try a 2. -2 times 2 minus 1 squared plus 3. All right, 2 minus 1 is 1. Squared is 1 times -2 is -2. -2 plus 3 is also 1. All right, let's try 3. -2 times 3 minus 1 squared plus 3. 3 minus 1 is 2. 2 squared is 4. Times -2 is -8. -8 plus 3 is -5. Hey, let's go ahead and try -1. We're just trying different numbers. Okay, -2 times -1 minus 1 squared plus 3. -1 minus 1 is -2. -2 squared is 4. Times -2 is -8 plus 3. That's also -5. Let's try -2. -2 minus 1. That's -3. -3 squared is 9. 9 times -2 is -18. Plus 3 is -15. I think we might have enough numbers. Let's try it out. Okay, so let's go ahead and graph. This here. Our x values are by ones, so 1, 2, 3, 1, 2, 3. All right, so the x values are by ones. The y values are by 5s, right? So we're gonna make them 5. 5, 10, 15, 5, -10, -15, right? 0, 1, 0, 1's about right here. 1, 3, 1, 3 is about right here. 2, 1, 2, 1's about right here. It's symmetrical, right? It's a parabola, so it's going to be symmetrical like a face. Same on both sides. 3, -5, 3, -5, -1, -5, -1, -5. And I think you can see your parabola. -2, -15, -2, -15. And also this will be 4, I think. 1, 2, 3. 1, 2, 3, yeah. Okay, so you see a U shape, so go ahead and draw your U. Okay, let's see what we noticed about the first parabola, your basic function, and your new equation. What happened? That's the question. What happened? What was the transformation? ¿Qué pasó? Well, it flipped down, right? We call that reflected over the x-axis. What else happened? Let's look at our vertex. What is a vertex for this equation? 1, 1, or 1, 3, right? 1, 3. The vertex is the highest or lowest point of any object. Highest, the peak vertex. Peak, right? 1, 3. Let's look at our formula. What do you notice? Vertex is 1, 3. What do you notice about the formula? Yeah, your vertex is right in your face, okay? So we're gonna look at that here in a second, so pay attention. From vertex to vertex, what happened? From this vertex to this one, it went up, right? From 0, 0, it went up 3, right? So there's a vertical shift up 3, which this tells you, vertical shift up 3. So we can start labeling these. We call this the vertical shifter, vertical shift. What else happened? From vertex to vertex, it went to the right, right? If it says x minus 1, well, this h is positive 1. This means to the right, right? So we call this a horizontal shifter. Left to right. So what do you notice about that, right? If you see x minus 1, that means you know it went to the right. 1 went to the right, to the right. Okay. What else happened? You can't really tell, but it actually got skinnier. You can't tell, but this 2 tells us that it vertically stretched. If this number is greater than 1, that means it's vertically stretching. So, horizontal shift to the right. 1. And the last thing it did, it vertically compressed. Now, if I showed you on Texas Desmos, you could see it better. Because the scaling of this is incorrect because this was by 1s. And I did these by 5s. Let's go ahead and put it into our Desmos. X squared. So graph your parent function and keep it red. Don't erase it. Keep it up there. Graph your new function. Negative 2 x minus 1 squared plus 3. Negative 2 times the quantity x minus 1 squared plus 3. You can see it now. From red to blue, the vertex went up 3. Vertex shifted over 1. This blue one, which one's skinnier? Yeah, the blue one's skinnier. We call that vertical compression, vertical stretching. Skinnier vertical stretching. And it flipped, reflected. So let's go ahead and write this nice and neat, all of our transformations so you can see it nicely. So, negative 2x minus 1 squared plus 3. So, here's your formula. Your A value is called your dilator. Dilator. If it's negative, it means it reflected. your H value is your horizontal shifter. And your K value is your vertical shifter. These are called translations. Translations horizontally, or translated to the right or left, translated up or down, vertical, right? So let's give some examples and write these translations down, these transformations down. If you see x minus 2 squared, right? Minus this one to the right, right? Minus went to the right. Horizontal, shift, right. If you see x plus 2 squared, and that's x minus h. Remember, the formula is x minus h. That's a basic formula. So if you see x plus 2, that means your h is negative. That's why it's to the left. Let's call this one to the right and this one to the left, right? If you see x squared and then plus 3, that's a vertical shift up. If you see x squared minus 3, that's a vertical shift down. If you see 3 times x squared, that means it got bigger, like it stretched more, got skinnier. So we call that vertical stretch. And it's skinnier, okay? If you see 1/3, this means your A value is greater than the number 1. 1/3, your A value is less than the number 1. 1/3 is less than 1, so it's going less, more down, more compressed. Vertical compression, vertical stretch. Remember, vertical's up and down, so you're stretching up and down. Vertically, you're going out, so compression. Okay, so what if you see negative 3 times x squared? Well, it's still vertically stretching because of the 3. That's the absolute value of A. The absolute value of negative 3, right, which is 3, is still greater than 1. So that's why it's vertical stretching. But that negative tells you that it's reflected. So it's stretched, but it's now down. If you see negative 1/3 x squared, then it's fat, but down fat. Okay, those are all your transformations. Make sure you write them down. Transformations. Make sure you know that the A value is your dilator, right? This skinnier fat. Your H is horizontal, K is vertical. If there's a negative, it's reflected.
We are continuing our random
And that is quadratic transformations. So you just graph it and see the difference. Keep this up here, don't erase it, and then put your new equation and see what happened.